Every time you use an app, make payments, or talk to an LLM, you are giving something away, most certainly your data, your identity, or your trust. I mean, we live in a world where everything is encrypted, ranging from social media platforms to websites, etc. But at the same time, nothing is truly private. But here's one truth you should know. Encryption only protects data when it is stored or in transit, and by transit I mean when it is moving from one place to another. The moment you use it, it has to be unlocked, and the moment it's unlocked, it is exposed. And in my opinion, that's not real privacy. I'll call that a temporary illusion. But there's a new type of encryption changing that equation, and this type of encryption is one that doesn't just hide data, but lets it think while staying encrypted. It's called fully homomorphic encryption, abbreviated as FHE, and a company named Zama is leading the way. Now, thank you for me because I've spent time studying how emerging technologies reshape trust online, and Zama stood out because it is fully functional, working code, open source, and built for developers. Now, let's start with what most people don't realize. When you send a message, your app encrypts it so no one can read it in transit. When you store a file, encryption keeps it safe on your device. But once that data needs to be processed, for example, by an AI model, a financial service, a hospital database, it needs to be decrypted first. And that moment of exposure is where privacy collapses. Everything from your health records to your spending habits can be analyzed, stored, or sold the second it is being used. So the million dollar question is, if encryption only keeps data safe when it's asleep, what protects it when it's awake? And that, my friend, is where fully homomorphic encryption comes in. So FHE allow computers to process data without ever decrypting it. To fully grasp what I mean, imagine this. You are cooking a meal, but the ingredients are sealed in transparent boxes. You can mix them, heat them, and finish the dish, but the boxes never open. That's quite frankly how FHE works. It lets you run computations on encrypted values, and when you finally decrypt the result, it's exactly what it would have been if you had done it on the raw data. So essentially, Zama is building the tools that makes this technology practical. Their open source libraries like Concrete and TFHE-RS are giving developers the power to build apps that respect privacy by design. By the way, Concrete is Zama's main library, which is like a toolkit that allows programmers to apply FHE in real-world applications. Essentially, it turns all that complex cryptography into something usable for developers. And TFHE-RS, pronounced TFHE Rust, is their Rust programming language implementation of FHE. It's basically a fast, efficient engine that handles the encrypted computations. In essence, Zama's technology is already being used to build encrypted AI systems that can learn without seeing private data, ranging from encrypted finance applications that calculate risk without exposing personal information, and even healthcare systems that can analyze patient records without ever revealing who the patients are. They've made FHE accessible for developers, something the world thought was years away from coming to fruition. And they did it by simplifying the math into usable frameworks that anyone can build on. In my opinion, I believe we're entering an era where apps won't just store data securely, but they'll operate securely as well. An era where privacy isn't the price of convenience, but the foundation of it. And without further ado, we've come to the end of the discussion. If this was valuable, I'd love to prompt you to like, repost, and comment your thoughts about Zama. Thanks for watching, and I'll see you in the next video. Peace.